All right, let's go ahead and jump right in. I'm glad you are here. Those of you that decided to come, um, you'll notice I just sent out an email to the whole class to remind people that coming in class is important. Um, Whether you're lost or whether you're keeping up, the stuff we do in this class does get more difficult. And I mentioned this early in the class, and people are like, yeah, right. Hello, world, that's easy. Well, the difficulty is starting to ramp up a little bit. So I'm glad that you're here. Uh, just a quick reminder that since you're here, if you're having trouble with something, please don't walk out of the classroom after the lecture without asking your questions. Make sure that you get help on the things that you need help with, that you're tracking with things, because every time we come back to this room, I'm going to layer another piece on top of what we've already learned, and it just keeps getting more and more difficult. So I don't want to have a situation where somebody falls further and further behind because they're not tracking with what's going on. So we talked about two different types of lists last time. We talked about lists or arrays, which is sort of the generic list type, and dictionaries. I'm going to introduce one more type of list, and that is called a tuple, and some people call it a tuple. I don't really care which way you prefer. I tend toward tuple, probably because I've been around Tupperware my whole life, and that just what comes out naturally for me. But you'll find the tuple debate right next to the GIF debate online. So it's kind of the same level of stupidity. It doesn't really matter. What does matter is that a tuple is a special kind of list. You'll know it's a tuple because instead of square brackets or curly braces that surround the list itself, you'll have parentheses. So if you have a variable equals and then a list with parentheses around it, you know it's a tuple. Like a generic list, a tuple is indexed. So I can refer to tup guys and then 0 in square brackets, and it will return the first value in that tuple. It's indexed the same way, starting with 0, 1, 2. And the big difference about a tuple is that it's static, which means you can't change the values, you can't add to it, you can't subtract from it. So you might be wondering, what good is a tuple? Well, a tuple is often used to pass multiple values into a function. A tuple can also be used to create settings for an app. So any set of information that you want to group into a single variable, but you don't want it to change, that's a good candidate for a tuple because they can't change. And so you know that if somebody tries to change the information in a tuple, that it will throw an error. So it's a safe and sort of protected way of grouping information together. You don't see them as often as the other two types, which is why I'm just going to mention them in passing, just so you know. You can just park it somewhere in the back of your brain. If you see a list, you're like, well, that looks like an array, but it's got parentheses. You'll know it's a tuple, and the values can't be changed. Mostly for reading other people's code. Like I said, there are a few functions that will require a tuple be passed instead of a single value, and you'll learn about those as you go. But that's our third type of list. And so if you want to compare the three types as to how they look, you'll know that a dictionary always has key and value pairs that are separated by colon. So key value, key value, key value, because it's not indexed by number, it's key indexed. And a dictionary has curly braces around it. For a regular list, we're looking for the square brackets and a list of values. And then, of course, a tuple we just covered has parentheses around that value. So the other interesting thing that we can do with lists, and I mentioned this, but I didn't demonstrate it before, is that we can have a list inside of a list. And in fact, you can have what are called nested lists several levels deep. You don't often see them go deeper than like 3 levels, although it is possible. It becomes impractical at some point because it just gets so confusing and messy for everybody. You don't really keep track. A lot of times it's just 2 levels, by the way. But if you want to look at this list here that I created, what you'll see here is I tried to organize it so that we could make sense of it a little bit easier. The top level list, the main list, has single letter variables or single letter values. The next list has double letters, and then the third one down has triple letters. So you can see L, the name of the list, slot 0 has A, slot 1 has B, slot 2 has another list. Right here, that whole list is into slot 2. Slot 3 is G, slot 4 is H. Now, if I unpack what's in slot 2, I can do this. I can print L slot 2, and it will print that array with the other array inside of it. So basically just this chunk. Okay, and if I wanted to access what's inside this, I would go slot 2, and then I would add another set of brackets. And the next set of brackets refers to this one. So if I go 2 and 2, I'm going 0, 1, 2. So I'm grabbing this whole array, and then I'm going 0, 1, 2 inside this array. So I'm getting this last most internal array with the triple letter variables, and it prints this. Now I can even dig into this one by adding another set of brackets, and I'll just get the first value of that array. In the abstract, without me giving you examples or having you play around with it, that can be a fairly confusing concept. So I want to play around with this a little bit because we can do the same thing with a dictionary. So if I want to, what I have here is a dictionary inside a dictionary, right? So here's my main dictionary, and each key is an integer, 1, 2, or 3. And for key number 1, I have this dictionary as the value with these two keys in it, name and price. So now, if I wanted to find out the price of a banana, I would use the name of the variable, and banana is number 3, according to the key. And I would say I want to know the price, which is a string. So if I want to print out the price of a banana, the price of a banana is $2.25. Or I could say something like, the price of a, and then I would use the name. And since that's a string, I can even capitalize that. I'm going to put this in quotes here so it's an actual string. The price of a comma banana is, and then I'm going to use the same thing here, except I'm going to use the price, copy the price. Okay, so now I'm saying the string, the price of a, and then I go up into dfruit number 3. It's not 0, 1, 2 in this case because I've assigned the keys, right? So let's see. My keys are right here, 1, 2, and 3. That's why this is 3. If I was using an index, it would be 2, but it's not an index. I'm just telling it 1, 2, and 3 are the IDs for that. So I'm using 3 and the name, so it pulls this, capitalizes it, and it inserts it. And then I go dfruit 3 price. So it goes to 3 and then price, and we'll print that. So now it'll fill in the blanks for that sentence from that array. Okay? But wait, there's more. Watch what I can do with a for loop now. Remember the for loop? We haven't played around with it much, but it's really useful for iteration, which means doing something to each piece of that dictionary object. So I'm going to say for each int key in I don't need each. That word does not exist in Python. For int key in the fruit. And so what it's going to do is it's going to go through each one of these and it's going to give me that number, 1, 2, and 3. So I can take this variable now and put it here, and I can put it here, and it will do that thing. It will print that line, but using that whatever that variable is at the time. So I'm going to go int key, and then int key. And now, when I run that, it gives me the price of each one, because key equals 1, then it says the name and the price. Then the next time it runs, key equals 2, and then it does the name and the price. And then 3, name and the price. So it's iterating through each piece of that array and giving me that piece of data back. So there's a lot we can do with nested lists and nested dictionary objects. And in fact, that's one of the basis for this assignment. We're going to do something that looks a little bit like this, but I'm going to force you to add one more field here that's salary instead of just these two, name and job. This is an employee database, okay? So each employee has an ID number, which is represented by the key that's an integer that we've assigned. This is not an index, it's a key because this is a dictionary object. So employee number 1 has the name of Bob and the job of manager, and he'll have a salary when you do it. Employee 2 has Kim and developer, Sam is, or number 3 is Sam and developer. So once again, we've got the key right here, and the value that goes with that key is this whole array. And inside this whole, this whole dictionary, inside this dictionary, we've got 2 key and value pairs. But we've defined now a set of data that we can do a lot of things with. And that is the assignment for A7. Now, A7 has 2 basic requirements. You must use nested dictionaries, just like the data structure I showed you. You must also use custom functions, which is what we talked about last week. You should be able to add and remove employee records, and it should include name, salary, and a position title for each employee. So it's very similar to this data structure, except you want to add a field for position. So first thing we're going to do is we're going to practice. And I'm not going to show you the exact code that you will use for this, but I'm going to give you a very close parallel. In fact, it's going to be so close that you can literally reverse engineer it. You can look at my code and figure out exactly what you need to do the employee database. I'm getting you that close on purpose because I want you to have an experience where you can see how that program is put together, but it's not done for you. So I'm going to walk through this code. We're going to create a fruit stand inventory app that keeps track of the name of the fruit and the price for a fruit stand. I am going to use global variables here inside my functions, which I know we've talked about the pluses and minuses of doing that. But for this case, in order to keep the app as simple as possible, I'm going to use global. You can absolutely do this without globals. I'm using globals to keep it simple and make it more accessible for everybody. Okay, so we're going to create functions for adding fruit and removing fruit and a few other functions that are sort of support functions. This code, or actually the code from this morning for this app, is already online. Now, what I'm going to do right now is I'm going to live code that. So there's no actual guarantee that I will write the exact same words in the exact same place that I did this morning. But the code from this morning is already on Canvas if you want to get that and follow along. Otherwise, I will upload this as soon as I'm done with it, and you can have an exact copy of what I went over in class. Okay, so first thing, I'm going to comment everything else out so that I can run these things as I go. But I've written some of the structure of this code out already so that we can kind of fill in the blanks. First thing I want to do though is I want to show you something, and that is this. If I just take a dictionary or even a nested dictionary like this one that's somewhat complex and I just print it, it will actually print out the whole structure of that for me, which is sometimes useful for debugging. You can see here. So when I print dfruit, I get the ID number, number one, not an index, but a key that I've assigned. The name, apple, the price, $1.25. Okay, second one is name, orange, price, $1.15. You get the idea. It'll print them all in one line like this, which is a little bit cumbersome to read, but you can at least kind of see what the structure is. And you can see that you've got a dictionary inside a dictionary because you've got name and value, key and value pairs here. So let's hide that for a second. And the first thing I want to do is I want to write a function that will list the fruit in the inventory or in this dictionary object. So I'm going to have a custom function called listFruit. And in this function, we're going to use a for loop, just like we did over here, to go through those. So for int key in dfruit, I'm going to first print the key because I want that to be available. And then I'm going to print a hyphen, and then I'm going to print dfruit int key and the name, right? Name, and then the price will be after that. So let's do, I'm going to capitalize that. And then I'm going to take the price for this part of it, and I'm going to turn that to a string. So I'm going to go str, and then inside that, I'm going to go dfruit int key, and then price. And since it's a string, I can do a write justify, and that way they'll line up. Now, if I really wanted to make sure I was okay, I would format this so that everything had 2 decimal points, but let's not get too crazy here. So now every time I run this, let's call that function listFruit. So I've defined the function here, and down below, I'm just going to call it so I can test that function out. I need to unindent that. So I'm just testing this function. Oops, hang on. str. Oh, my bad. Put that parenthesis in the wrong place. There we go. All right. So we've got apple, orange, banana. I've got a little justification problem here, but I'm going to ignore that for now because I don't really care that much. But it's printing everything out in the right way. So if I change this to lemon instead, okay, and then you can see it changes it when it prints it out. That's all good. So now I have defined this listFruit function. So every time I want to have it do all of this, all I have to do is this, which means my code gets a little shorter down below or in other places. I can reuse this anytime I want. When we write custom functions like this, a good way to think about it is a custom function is a miniature program or a tiny program that lives inside your main program that does really specific things. But it makes it easy because if I just run list fruit or I call list fruit, it'll do that same thing every time reliably, which is great. So now let's create a function to add fruit to the list. So when I want to add fruit, in this, if I want to add another line or another member to this dictionary, I need three pieces of information. I need the name of the fruit and the price of the fruit, and I also need to figure out what the next number in the sequence is going to be. Now, you and I can look at this and say, well, you have 1, 2, and 3. Obviously, the next one in the sequence is going to be 4. But Python's not smart. It can't figure that out by itself. So what we have to do is we're going to have to tell it how to figure that out. And we'll do that in a minute. But first, let's kind of go through this function and do the other pieces. So we need, from the user, we need to get the name and the price. So we're going to call that strfr name. And we also want to remember, we're going to write out to the global value. So we want to make sure that we use the global keyword for dfruit so that as we write to that dictionary, we can do that. So we're going to get the fruit name using input. And it's going to come in as a string already, so we don't need to do anything else with it. Name a fruit. And we're going to get a float price. Input, what is the price? Okay, and I want to change that to a float. If I was being really careful, I would check to make sure that it was an appropriate number that could be turned into a float. Right now, I don't really care, so I'm just going to turn it into a float right here on the fly. And if somebody enters the word George, we're going to have an error, and that's okay because we're kind of focused on something else for this assignment. So I've got the name, I've got the price. Now all I need is the ID number that goes in the key slot. Now I need to find out what the ID number is, and so I'm going to use a different function for that. So I'm just going to say get new ID, and in my mind I just am going to pretend like I've already created this function, but whenever I call this, it's going to look at that dictionary and send me back an appropriate number for the ID. So now, last thing is just to take that information and use it to create a new line. So what I'm going to be doing, oh, it's coming down again. Here we go. I've got dfruit, and I'm going to use the new ID to say I'm going to specify this. So dfruit, specify the ID, and then I'm going to tell it this value. Well, the easiest way to do that is if I just create another dictionary, the new fruit equals the dictionary object name, and then I'm going to use str fruit name and price. Oops. Price and int or float price. Float price. Okay, so I'm creating the new fruit with the name and the price in a dictionary object, and then I'm going to say we're going to add that to the dictionary dfruit at this location equals that dictionary object. And then the last thing I'm going to do is fruit added. Here is your current list. Okay, so I've got that message there, and all I need to do is call that function that I already created, list fruit, and it'll just take care of listing the fruit for me. Okay, so now all I have to do is go back and create this function, get new ID, so that it will work. So I'm going to create that. It's not going to be too difficult. Basically, what I need to do is I need to get these numbers, and I need to sort them, because I need to figure out which is the biggest number out of all of these numbers. So I'm going to sort them from biggest to smallest, and then just take that biggest number and add one to it. So that's what get new ID does. So first we're going to create an array. I'll just call it ARTemp because this array is going to exist for about 2/100ths of a second, and then it'll just go away. So it's only going to exist while I run this function. So ARTemp works just fine for this. And I'm going to create an empty array. And then I'm going to say for int key in dfruit, let's use global to make sure that we're able to do everything we need to here. Global dfruit. So for int key in dfruit, for each time we're going to take that key, ARTemp, and we're going to append it to that array. So what that means is we're going to end up, once it goes through each of those, we're going to end up with an array that's just a list of numbers. And then we want to sort it. So we're going to go ARTemp, sort, and we want to sort it in reverse order. Reverse equals true, which means after all of this, we're going to have a list of numbers that are sorted from biggest to smallest. That's what reverse equals true does. It sorts them in reverse order, so descending order. And then we do return ARTemp, and we want the first member of that, the first number, which is the largest, plus 1. So every time, it's going to sort all of these, find out the biggest one, add 1 to it, and send it back to this variable, which means it then gets added on as the new dictionary object. So we've got everything we need to add a new fruit. Let's just try this out. Add fruit. So I'm actually just going to call the add fruit function, and we'll just try out that part of this. See, this is one of the things that makes debugging easier with functions, is that I'm taking each piece of the program and I'm putting it in its own little space. Then I can test it and mess around with it there, and it makes it a lot easier. So name a fruit, watermelon, 525. Okay, so there is my new list of fruit, watermelon 525, and ID number 4. So that's all working exactly the way we wanted it to. So that's good news. And so I'm going to delete that. So we're no longer calling that function. And now I'm going to do the remove fruit function. So let's talk about how do we get rid of fruit. First thing, of course, we want to do global dfruit so we can access that global variable. And then we want to list the fruit again. So here's that handy function, the list fruit function. There it goes. And then str choice equals input. And I'm going to change that to an int input. Enter the number you want to delete. Okay, next thing, oops, got to put a parentheses there. Next thing is we are going to say dfruit pop str choice. And it should be int choice because I'm changing it to an int. I should follow my own rules probably. And then print you have removed the fruit. Here is your new list. And we will list the fruit again. Okay. So remember, we're going to use pop, and we're using the index, which is what the user enters. And so that I could put that in a variable. I don't have to, but if I wanted to put that into a variable, I could use it down here to give intelligent feedback about which fruit got removed. I'm just not going to do that right now. So now, look at, we have list fruit, we have add fruit, we have get new ID, and we have remove fruit. So we've got really handy functions right here that all act on this D fruit. And so now look at what I can do. I can just collapse those and they're completely out of sight. All I have in front of me is the names because that's all I need. This is the great part. This is the most fun part of working with functions, is that now as I go to put together the main program, my programming gets really easy. So I'm going to put the main program loop here, while true. So let's make a menu choice. str menu equals input, and I'll say 1 for add, 2 for delete. And so I'm going to put a blank line in front of there, and let's list the fruit right there. And then we'll just say if str menu equals 1, guess what we have to do here? Almost nothing. We just tell it add fruit. If they choose 1, we're adding the fruit. Elif str menu equals 2. If it equals 2, then we just remove the fruit. And then we have, of course, else print invalid input. Okay. And then we're just going to ask would they like another transaction. str menu 2 equals input yes or no. And then if they say no, we're going to say goodbye. If str menu 2 equals n, then print goodbye and break. And that's it. Look at this. This, like the whole core of your program is right here in these like 4 or 5 lines. It's super readable. And now if I have a problem in my program, well, most likely it's not going to be here, but I'll be able to go back and know exactly where that problem is happening. And I'll be able to just focus on that one little piece of code and ignore everything else. So let's run this. Okay, so here's my fruit stand. 1 for add, 2 for delete. Let's go 1, name a fruit. Guava, 235. Okay, fruit added. Here's your current list. Another transaction. Yes. Let's delete one. Enter the number you want to delete. There we go. That's the whole program. And by the way, it is exactly the same structure as this. Very similar. In fact, you can go back in and you can take those parts and you just substitute employee for fruit, and you need to add a third field in that database model so that you have name, salary, and position. Right now we have the fruit name and the cost, but you can see the similarities there. You can easily take the pattern from one and apply it to the other. Again, that's not just because I'm a dumb instructor and accidentally gave you all the answers. It's because I want to get you like 80% of the way there and have you play around with what it means to put that together. Because next time we'll come back and we'll add a little bit more difficulty to this. So I'm just moving you along, hopefully slowly enough that everybody's keeping up. But again, if you're having trouble, if you're struggling with the earlier assignments, the later assignments aren't going to get easier magically. So let's do this in order and build it up as we go. So, all that said, any questions about this assignment, the code, anything else? Okay. I think after doing the code, it's safe to say that the code that I put in there before, it has the same functions, it has the same stuff. It's almost identical, maybe save a few punctuation marks here and there, or a different snarky comment as feedback for the user or whatever. But essentially it's the same code, it's on Canvas. Start there, download that code, and start thinking about how can I change this from a fruit stand to an employee database. Okay, and then let me know if you have any trouble.